All right, so we left off yesterday looking at the shifts, shifting left and right, up and down. Today we're going to look at the stretches, left, right, up and down. So first thing we're going to talk about is when you have a sine or cosine function, what is the amplitude? So the amplitude basically measures the height of the wave. Okay? It's from the center line to the peak. It's also symmetrical from the center line to the low point. That part right there is called the amplitude. The amplitude for sine and cosine is normally what?
One.
Think of the standard sine and cosine. Yeah, it's 1. Now, if we stretch it, we can either make it taller or compress it and make it shorter. When you do a vertical stretch, where is the number in the problem that tells you, okay, this is a vertical stretch by factor of 2? Where would the 2 be? Yep.
Like right after the y in front of it.
Yeah, it would be right after the equal sign in front of
Sine, cosine.
the function. Yeah. And I use the letter C because when we do all 4 transformations in a little bit, it's the third one you would deal with. So an amplitude change has the form number times the trig function. Now, if I ask you specifically, what is the amplitude? The amplitude is a distance. So if you're measuring a distance, that's always what kind of number? Yeah, positive. So even if I wrote something like this, you wouldn't say the amplitude is -5. The amplitude is the absolute value of the number in front, which in this case would be 5. Does the negative still cause something to happen on the graph? Absolutely. What does a negative in front do? It's vertical reflection. But this has no effect on the amplitude. Okay, so when you want to know the amplitude, you take the absolute value of the number in front. When you're graphing it, do not take the absolute value. You have to use the negative as a reflection. So amplitude is always positive. And an amplitude change is going to stretch or compress the graph vertically, okay, along the y-axis. So let's just try a couple where we don't even graph it, just find the amplitude. Okay, y equals 3 cosine x. What do you think the amplitude is? Yeah?
3.
3. All right. How about 4/3 sine x plus pi over 2 plus 6? What's the amplitude of that one? Yeah? 4/3. There's all kinds of other stuff happening, but shifting left and right and shifting up and down has nothing to do with changing the amplitude. Shifting up and down could change the range, but not the amplitude. Everyone understand the difference between the two? How about -2 sine x? Amplitude? 2. What would be the amplitude now if I did that?
It'd stay 2.
It'd still stay 2. Yeah. But with does the negative cause something to happen in the graph? Yes, and we need to do that when we graph. Yeah.
Just scroll up a little bit, please, to the name of the example. Thank you.
So when we are trying to take those 5 points I gave you yesterday and change them for a vertical stretch, which column isn't affected by stretching vertically? Which column in the table stays the same? Yeah, yeah, the x's. Okay, so the x's are going to stay the same, and we copy those down from the original table. Not sure if someone... So copy the x's. So your x's are going to be 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, those are going to be your x's. Now, if the x's are going to stay the same, the y's are going to change. how do they change? Take all the old y values and multiply them by the number in front. Notice I didn't say anything about absolute value. You just use the number that's in front the way it is, because the negative is important when you're doing the graph, if it's there. Okay, so arithmetic is pretty easy. Just multiplying all the old y values by the number in front. All right, let's try this one. Y equals 3 cosine x. Okay, first, what kind of transformation is that? Yes?
A vertical stretch.
Yep, it's a vertical stretch because it's multiplied by a number in front. So which column here stays the same?
Yeah.
X's. And what are my X's for cosine? This is the table from yesterday. Yep.
0, pi over 2, pi, 3 pi over 2.
Now let's put the original y's off to the side. 1, 0, -1, 0, and 1. And they're all going to get multiplied by what in this case? 3. So times them all by 3. Okay, so what are my new y values going to be? Yep.
3, 0, -3, 0, and 3.
Perfect. Okay, again, the table is the most important thing in the problem. That's going to be worth 10 points on the test. 1 point for each x and y. And then the sketch, it'll probably just be a couple of points for the sketch. Okay, because the table is a lot more time to figure that out. Okay, so now for your labels, the 0, pi over 2, pi, those are all equally spaced. So use them as your labels. 0, pi over 2, pi, pi over 2, 2 pi. And I have to go from -3 to 3. Well, the way I usually do it, I just scale my y-axis to go by 3s. That way, if I had to graph like 50 sine x, it's not like 50 times as big, right? So I just scale it. You don't have to do it that way. If you want to draw in all the tick marks, you can do that too. Okay, 3, 0, -3, 0, 3. 3, 0, -3, 0, 3. And there's your graph of cosine, and it's been stretched 3 times as much. It won't look like it's stretched 3 times as much because I scaled my y-axis. Yep.
Do you, on tests you have to label the x value, label the x-axis with what each thing represents? Because you have the x values on the bottom.
That will kind of be taken care of for you, the way I have the questions set up. Yeah.
If it was like written hypothetically, would like to get it correct, would we need to in like an exam or something have to put on the x value, like label the x with x value, how much each?
They'll be labeled for you.
Even on like exam thing.
Yes. The table is going to be blank though. You're going to have to fill in the entire table.
Okay.
Yeah. Yeah.
Thank you.
Yep. Okay. What kind of transformation is this one? Yeah.
Stretch.
Yep. It's another vertical stretch. So x's are going to stay the same. And can anyone tell me my final y values for sine that I should put in that table? Yep.
1/2. Oh no. 0. 1/2. 0. -1/2. 0.
Yeah. So if you did the 1, that would be 1/2 cosine. Yeah. And there's your table.
Wait a minute, go back to the last page. The last page.
Why is the first x on cosine 1? I thought that was.
The first x value is 0.
I mean, y value. I thought
The first y value is 1. That is just the way cosine is. Starts at 1. Now I'm going to do the same thing. I'm going to put this as a half. Negative a half. This will be 0. Pi over 2. Pi. 3 pi over 2. 2 pi. 0. 1 half. 0. Kind of like that. Yeah. Any questions on it?
Nope.
Bless you. Hey, this one I'm not going to sketch it. I just want to do the table. Is there a change in the amplitude happening in this problem? The amplitude is still 1. There is no change in the amplitude. So then what's happening? Something's happening, yeah? Right, it's a vertical reflection. It's reflecting over the x-axis. So we still treat it the same way we would do a vertical stretch. You're going to multiply the y values by a number. It's just, this time, they're only going to change sign. They're not going to change the value of it. It's still going to be same number, just change the sign to either a positive or a negative. So our x's stay the same. And what would my y's be for negative cosine x? Yep.
Negative 1.
Yep.
0.
Yep.
1.
Yep.
0.
Yep.
Negative.
And negative 1. So we start down, we go up, up, down, down. There's our graph. So the cosine gets flipped. Okay. Any question on the table? Okay, so the last individual transformation is a horizontal stretch or compression, and that's called a period change. How long is the normal period in sine and cosine? Or how long is a cycle? Yep.
360 degrees
Or
2 pi
2 pi
radians.
radians. Yep. So normally it's the 2 pi radians, but now we're going to change it. We're going to stretch and compress it. Where do you look for the number if it's a horizontal stretch? Is it plus a number outside? Is it minus a number inside? Like, what do you look for? Yeah?
Isn't it like a coefficient inside the axis?
Yep. It's a number in front of the x. And it would be the second transformation that we deal with if we have to do multiple in the same problem. It's the same order I've been showing you all year. Now, if you make b a big number, what does that do to the graph? If you make b big, yep, it compresses it. So if I graph sine 8x, that's going to be very compressed compared to sine x. The bigger I make b, the more compressed it gets. The smaller I make b, if I make b 0.5, now that 0.5 is going to cause it to stretch. It causes it to stretch. We're only going to look at examples where b is greater than 0. So we're not going to do a horizontal reflection at the same time that we do a horizontal stretch or compression. It's just, that's all we're going to look at. So stretches or compresses a graph along the x-axis. That's everything I already told you. If b is bigger than 1, it compresses. If b is less than 1, it's stretched. And like we did with amplitude, there's going to be some questions on the test just about period. Okay, just about period. So I'm going to ask you, what is the period of this graph? So if you had this, what's the period of sine x?
X?
Period's going to be a number.
One.
The amplitude is 1. The maximum value in the range is 1, but the period is definitely not 1. Yeah? It's 2 pi. What do you think the period of sine 2x would be?
4 pi?
So does 2x cause the graph period to shrink? Or does it cause the graph period to stretch?
Causes it to shrink.
Causes it to shrink. So if it was 2 pi, it's going to shrink. It's going to be smaller than 2 pi. What do you think it would be this time? Yep. Yes. This would have a period of 2 pi. This would have a period of 1 pi. The shorter the period, the faster it oscillates. And in general, the formula to find the period is 2 pi divided by b. You take 2 pi and you divide by the number that's in front of x. That's why when we did sine 2x, the period came out to pi. And so that's the formula to calculate the period of a graph. No picture needed to do that, just a formula. We'll try a couple of these. Sine 2x. We just did that one. Not the period. What's the b value in this problem? B is 2. So now what's the period? Pi. Yep. Okay. Let's try this one. Okay. What's the b value? Yeah. 1/3. So the period is 2 pi divided by b. What's the period? Okay.
It's going to be changed into 2 pi times 3, which would be 6 pi.
Perfect. So 1/3 causes the graph to stretch 3 times as much. Okay. How about the period here? Yeah. Well, the b value is pi. I guess that's what I've been asking for all along.
Period just be 2.
The period would be 2. And what about the period in this one? Final answer. Not the b, just what's the period? Yeah. Yeah. 2 pi over 3. What would be the period now? Still 2 pi over 3. Shifting up doesn't do anything to the period. It shifts it up. Changes the range. Doesn't change the amplitude. Doesn't change the period. Right? So you have to know what number you're focusing on. All right. So when we stretch and compress horizontally, think about the table. What values are going to change? Things are stretching and compressing horizontally. Yeah?
The extra.
Yeah, the x's are going to change and the y's are going to stay the same. Unfortunately, the y's, those are the easy ones to work with. We don't get to work with those this time. So you're going to copy down your y values from the original table. And how do you get your new x values? You're going to take all the original x values and divide them by b. Now, sometimes b is a fraction. So what I might do sometime is instead of dividing by a fraction, I'm going to multiply by the reciprocal. But that's how you do it. Take the original x's and divide by b.
I'll be sure.
Yep. Okay. So let's try 6. So we know that that is a period change because there's a number in front of x. You have I think someone said like a coefficient. That's what it is. Okay, so with a period change, which column is going to stay the same? Yep. Yep. And can you tell me my y's for sine?
0, 1, 0, -1.
Perfect. I need a little bit more space.
Thank you. All set.
What's that? Okay. What are my original x values for sine? Yeah.
0, pi over
If you keep going, I'll catch up. And now it says take all the x values and divide them by b. So what would we be dividing all of those by? Yeah? We can divide them all by 1/2, which is the same as doing what? Times 2. That's how I'm going to do it. Times 2, just easier for me to think of the math that way. And if you times them all by 2, you get 0, pi, 2 pi, 3 pi, 4 pi. Times them all by 2. Yeah.
Like, I know when you divide by a fraction, you multiply by the inverse of that, but you're multiplying by a fraction, so...
Multiplying by 2. Not by a fraction.
But so, for the transformations, divide them by...
Either divide by b
Okay.
or multiply by 1 over b.
Yeah, so that would be divided by... Okay, thank you. Divide by half.
Yep, divide by half or multiply by 2.
Yeah.
Yep. Okay, label your axes. Use the marks that we just created. They were all equally spaced before, and we doubled all of them, so they're still equally spaced. All right. 0, pi 1, 2 pi 0. Doesn't look like I stretched it bigger, but that's because I changed my tick marks. I'm not going by pi over 2, pi. Each tick mark now is 180 degrees. It's not 90 anymore. And that's because I chose to do it that way. Any question on that? Right, let's try this one. So in terms of stretching and compressing, this is the opposite of the last one. This is a bigger number. It's going to compress. Okay, so we've got x, y, and which column stays the same? Yeah, y's. So hopefully, you're starting to remember what those are. 1, 0, negative 1, 0, 1. Okay, original x's, I'm just going to put them for reference. And now we're going to take all of those x values and divide them by 1. Divide them by 2, which basically means take half of it. So I'm going to have 0. What's half of pi over 2?
Pi over 4.
Pi over 4. And then half of pi is, well, just say half of pi. I didn't line these up well, sorry. Okay. What's half of 3 pi over 2? 3 pi over 4. And what's half of 2 pi? 1 pi. Yep. So we divided all the x values by 2. Okay, so now each tick mark represents how much? Yep, each tick mark now is representing 45 degrees. So it's going to look the same because I'm changing my scale. All right, so we got 0, 1, 0, -1, 0, back to 1. There you go. Okay, that's really how period changes work. Any questions on that? Yeah.
Is the fact that the 2x and modern parentheses do anything?
No, it wouldn't make any difference whether you do that or that. No. The 2x is still the entire argument. Now, what could be misinterpreted a little bit is if you had something like cosine x plus 3. Technically, without the parentheses, that's a vertical shift of 3. If you really wanted to make it super clear to somebody, although not necessary, you could do that. And now there's absolutely no confusion. But there's nothing wrong with the way I wrote it before either. In fact, on a test, you might see something like that. And that's a shift down 5. That is not a horizontal shift unless you group the letter and the number together. Now it's a shift right 5. Okay. Anything else on that? Okay. So the last thing we'll look at is multi-step transformations. And we just have to remember the order that you always go in when you have multi-step. Can someone remind me, what's the first transformation you always deal with in a multi-step?
Horizontal shift.
Horizontal shift. Yep, we call it a phase shift, but it's a horizontal shift. What's the next one? Yep.
Horizontal stretch.
Yep, your horizontal stretch. Okay, again, we call it a period change for this, but it is a horizontal stretch. You could have a reflection here, but I told you we're not going to do those. What's the third one? Yeah?
Vertical stretch.
Vertical stretch. Okay, that's an amplitude change. It changes the height. And what's the last one? I don't think we didn't have an alternate name. Yeah?
Vertical shift.
Vertical shift. Yeah.
Wouldn't we just call that like the period shift? I mean, the amperage shift.
Which one? Vertical shift?
Number 4.
I've never heard of it.
I mean,
Anything other than
just based
that.
on the others, because of like if there's because the vertical shift is like the horizontal shift, so we can just call it a amp shift.
Yeah, sure. I've never heard of it, but
Okay.
maybe. I'm not saying that doesn't exist. I just don't know.
Yes.
Yeah. Okay, so that's it. When you're doing a problem with multi-transformations, just always do them in that order. Other than that, there's nothing new to really explain. All right. So what I usually do is I make 2 tables. I do the first transformation, and then I do the second one. Or you can do it all in one table if you think you can do it. Okay. What number are we going to focus on working with first? Yeah? Right, the pi over 2. And what is that going to do? What kind of transformation? Yep.
So then horizontally shifted to the left.
Yep, it's going to move everything to the left. Now, that's going to move everything to the left. Is this 2 horizontal or vertical?
Vertical.
Vertical. So technically, you have 1 horizontal and you have 1 vertical. Those are 2 separate axes. You can do them in either order. It won't really matter. Where it starts to matter is when you have 2 transformations on the same axis, like shift right and compress horizontally. Now it makes a difference which one you do first. Technically, these are separate axes. Yep.
Sorry. When you could just do one table because like, you're doing all the x's.
Yeah. So we could really do it with one table because it's 2 separate transformations. So what do we do to all the original x's?
Minus pi over 2.
Okay, so we're going to minus pi over 2. I'm going to assume people are okay with the numbers I just wrote down.
Yeah.
How to do that? Okay. And now let's put the original y's. Okay, I'll put those on the outside. And what are we doing to all the y values?
Wait, this is sine function.
Yeah, you're right. It's you got to fix those. Thanks. Never happened. All right, so I got all my y values. And what am I doing to all of them?
Multiplying by 2.
Multiplying by 2. 0, 2, 0, negative 2, 0. That's all I'm going to be looking for on the test in terms of a table. I want to know the final answers. So 1 point for each x and y. Now we just graph it. Okay. Let's see, I have one negative value that I need, so I'll start over 1 tick mark. 0. Pi over 2. Pi. 3 pi over 2. And I gotta go from negative 2 to 2. So I'm gonna scale it like that. Okay, so negative pi over 2, we're at 0, 0, 2, 0, negative 2, back to 0. Okay, so two things happened there. We did a shift left, and we stretched it by a factor of 2. You can't tell because I scaled my axes. And that's a multi-step. Multi-step could have 2, 3, or 4 transformations. I guess it could have 5 if it had the reflection, but we're not going to do the horizontal reflection. Just there's enough going on. So.
Every unit is 90 degrees in this one, right?
Yeah, there was no period change. If you don't put a number in front of x, it's always 90 degrees.
Okay.
Yeah. All right. Anybody want to see like another multi-step one? Okay. So then let's do the calculator one. So it says find a complete graph. That means on the calculator of that, and then give me the domain, the range, the amplitude, and the period. Well, domain, you should never even think about that for sine and cosine. It's a wave. What's the domain for all sine and cosine? All real numbers. Okay, and even the range, we can kind of figure it out. What's the normal range for sine to cosine? Yeah? It's normally negative 1 to 1. Is there any number here that is going to affect the y values?
That's real.
If no, then the range is negative 1 to 1. If yes, then we need to fix it. Is there a number there that would affect the y's? Yep.
4.
The 4.
Vertical, that would just make it, that wouldn't shift it, that would stretch it. No, that would,
Stretch it.
yeah, that would stretch it.
So what would my range be? Don't worry about the 3. That's not going to affect the range. Just the 4. Yep. Yeah. The range is going to be negative 4 to 4. Because it was negative 1 to 1, and you stretched that 4 times as much. So we got those two. How about the amplitude? Yeah. Nope. Amplitude is not 3. The 3 is important for the period. It's not the period, but it's part of the formula to find the period. So we do need the 3, just not for the amplitude. Yep. Amplitude. We're looking for the amplitude right now. Amplitude usually doesn't have pi in it, unless they did something like this, which would be kind of weird, but they could. Yep. 4. The amplitude is 4. It's the absolute value of the number in front. Now, what's the period? Yeah. That's 2 pi over b, which is 2 pi over 3. Okay, let's graph it. Now, since you guys gave me the period in radians, because that's the formula I gave you, I'm going to need to put my calculator in radians. If you did it in degrees, the period is 120 degrees. we did radians. So I'm in radians. Type in 4 sine 3x. And what would be a good value for my y min and max? Yeah.
Positive 5, negative 5.
Yeah, I would do positive 5, negative 5. And let's say I want a window that shows exactly 2 periods. Well, 1 period is 2 pi over 3. How much is 2 periods?
180 degrees.
In radians. I want to do radians.
Pi.
No. 1 period is 2 pi over 3. So how much would 2 of those be? 4 pi over 3. So what would be an x min and max that I could use that would have a difference of 4 pi over 3? Because that's how wide I want my window to be. Yeah.
2 pi over 3 and negative 2 pi over 3?
You could do negative 2 pi over 3 to 2 pi over 3. Yeah, that would work fine. I was thinking of a different one, but that's fine. Yeah.
Pi over 3 and 6 pi over 3?
Pi over 3 to 6 pi over 3, that's not a difference of 4 pi over 3. Pi to 6 pi is a difference of 5 pi over 3.
Oh, I thought you meant 2.
I was thinking of just doing 0 to 4 pi over 3. That will show you exactly 2 cycles of your graph. Okay, so if we did it right, there's your first quarter, 3 quarters, that's 1 cycle, 1.5 cycles, and 2 cycles. So I may ask you for a window that shows 2 cycles or 3 cycles. And so you just have to take your period and set your window to be as wide as that. If you wanted to see 5 periods, you would have to do a window width of 10 pi over 3. However you want to do it. I would just do 0 to 10 pi over 3. That's the easiest way. Yeah.
Period is like a full rotation thing.
Yeah, 1 full cycle of the graph. Yep, so there's 2 full cycles here. If I wanted 3 full cycles, multiply the period by 3. So make it 6 pi over 3. Or 6 pi over 3 is really just 2 pi. So if you do 2 pi, now you should see exactly 3 cycles. Okay. Any question on setting up the window for that one? All right, and we did everything else. Domain, range, period. Perfect. All right, let's try this one. Find a complete graph, and then domain, range, period. Okay. Okay. Domain, all real numbers. Okay. Range. Think about what it would be, and look if there's a number there that would change that. Yeah. Yes, you're doing a vertical stretch by a factor of 3. You're doing a shift right 1. Well, shift right 1 doesn't have anything to do with range, but this does. Takes negative 1 to 1 and stretches it 3 times as much. Period. What's the period? Yeah. 2 pi over what? Period is a measurement of length, so it can't be a negative number. What's b in this case? Not negative 1. That's a horizontal shift. Yeah? No, b is the vertical stretch. B is vertical stretch. Yeah? B is 1. B is the number that is in front of x. So there is no period change in this problem. You're not changing the period. So the period is 2 pi.
Please excuse this interruption.
Okay, so period is 2 pi. And how about the amplitude? Yeah? How much? 3. It's the absolute value of the number in front. Okay, what would be a good value if I wanted to show 2 cycles of this graph? Yeah?
4 pi.
4 pi. So I would say set a window that's 4 pi wide. 0 to 4 pi is easy. Y min and max, you can do negative 5 to 5. And then just type in your problem. 3 sine x minus 1. I got an extra parenthesis. Okay, we should see exactly 2 cycles. So there's 1, and it should end right where that one started. And there's 2. It's not a rule you have to show 2 cycles all the time. I'm just trying to see if you know how to do a certain number of cycles. Right. So I would put those as your window. It will change those to decimals. So even though you put 4 pi in, it changed it to 12.56. I would write down 4 pi for x max though. Okay, any question on that? I don't know if I'm where. We talked about that. I told you that sine and cosine are really the same graph. One of them is just shifted 90 degrees from the other. So we're not going to do a lot with these right now. But if you take sine and you shift it 90 degrees to the left, it turns into cosine. Or if you take cosine and shift it 90 degrees to the right, it turns into sine. Okay, so these are called horizontal shift identities. We are going to use them. I just don't think they're super critical for what we're going to do next. So if you don't write them right now, you'll have a chance to write them in a future lesson.
Are we going to learn how to make a sine or cosine into like a tangent line?
You already know how to do that.
Like I know that sine over cosine equals like a tangent line, but like I mean mathematically like that.
That's how you would do it. You'd use the tangent identity to do it. You can't shift a sine or a cosine just a simple left and right and turn it into a tangent. Because a tangent is a totally different looking graph. Tangents have vertical asymptotes in the graph, and they're totally different. So the only way to turn a tangent into a sine or cosine is the formula I already taught you. Okay, so the last thing that's, these are all the same question, is solving a trig equation on the calculator. Now, there's lots of ways you can do this without a graphing calculator, but the focus of this is just going to be on a graphing calculator because we're talking about graphing. So, how do you think you would solve where this graph is equal to that graph on the calculator? We've done this before. Yeah.
You graph like both the lines and then see where one's higher than the other, or wherever it is greater than or less than the two.
Well, you might look for greater than or less than sometimes, but you're not in this one.
You graph both the equations.
Yes.
And then you see
where
they intersect.
Yes. Where they intersect. If it was an inequality, like where is the sine of x greater than or equal to 0.4, then you might have to do a little more and say, okay, it's anything above this number. But our answer is just going to be exactly this number. Yeah.
Couldn't you find that by dividing x by sine and then dividing 0.4 by sine, which would just be finding cosecant of 0.4?
No, you can't divide by sine here because this is an argument to a function. So the only way to get rid of a function is to use a function which is the inverse of it. So like if you had square root of x equals 3, you can't say anything like divide both sides by square root or something to like try to cancel the square root.
Yeah.
The only way you can get rid of a square root is if you square. The only way to get rid of sine is with what's called inverse sine. We're going to talk about that at some point. But yes, you can do this algebraically. And you can do it algebraically actually a lot faster than graphing it. One of the answers that we should get when I do the intersect is 0.4115. And the other one, I'll just do it quickly and see. We're looking for positive sign value, so it's pi minus that last answer. You're going to learn how to do what I just did eventually. So let's see if those are the two answers we get. 0.411 and 2.73. If you don't know how I got those, don't worry. Let's just see if that's what we get. So I put in both graphs. And what's the x-min and x-max that they want me to use? Sometimes you get to pick, you don't hear. They're telling you. Yeah?
The minimum 0, max 2 pi.
Is 2 pi. And the graph of sine goes how high and low normally?
1, 1, negative 1.
Yeah, so it goes -1 to 1. We don't want it to go off the screen because we might not be able to see what's happening. Okay, so there's our graph of sine from 0 to 2 pi. It's one cycle. And now let's calculate those intersects. And keep in mind those numbers. All right, let's go to our graph. Second calc intersect. If you just hit enter, you'll get one of them. Is that one of the numbers I had on the other screen? Yep. And second calc intersect. Move it closer. And I get 0.4115. 0.4115. So you can see it isn't hard to do what I just did there. I'm just going to not show you that yet, but I will eventually. All right, so those are your two answers. So x is 2.73. 2.73, and what was the other one? 0.411 or something? So that's all you need to understand how to do for these. Let's try this one. Now, one thing I want to mention is when you're looking between 0 and 2 pi, I don't know if you noticed, this had the equal, this one didn't. That's because 0 and 2 pi are repeats. This point here is exactly the same as that one there. It's the same point in a later cycle. So generally, when they have you find the answers, you find all answers in one cycle. So if your horizontal line was right here, you would not say that you have 3 answers. You have 1 answer, 2 answers, and then this answer is really the start of the next cycle. That's why they don't put the equal to under the 2 pi. Okay. So same idea here. Okay, what's going to go in y1 this time? Yep, you put in the equation on the left. If you want to avoid the fraction, you can just do 2 cosine 0.5x. What goes on the right?
1.5.
1.5. Now, I thought the graph of cosine never went above 1. So is it ever even going to hit 1.5?
It's a stretch.
It's a stretch. So it's stretching it by a factor of 2. So yes, it will hit 1.5. I should have adjusted my window, but it's okay. It'll work. And because of this 1/2, you've stretched the graph horizontally, so you're not going to be able to get the second answer on the screen. If you compressed it back, you would. But you're only going to get one answer this time. And it's 1.45. Okay, so sometimes you get 2 answers, sometimes you get 1 answer. If you squish it a lot, so if you had a graph that maybe did something like this, I mean, then you could get a lot of answers. That'd just be kind of tedious to have to do them all. So it's usually two or less. Okay, any question on that one? It's pretty much the same thing. Just put that in y1, put that in y2, and then see where they cross. Any question how you would do that one? The difference this time is you're not going to have a wave and a line. You're going to have a wave and another wave. So you're going to have a sine and a cosine. And you just see where they cross. All right, so let's finish up with this one. So this is kind of like I think what Rich was saying earlier. When you have an inequality, the answer is not necessarily equal. It's a lot of times it's between this and this. All right, so let's try this. So we've got 2 cosine x, negative 1.3, and we're looking for where the cosine function is going to be above the horizontal line at negative 1.3. Right, 0 to 2 pi, that's a pretty standard window, so you'll see that a lot. So we're looking where we are above negative 1.3. Okay, so you tell me, what do I need to do first?
Find the intersection.
I got to find these intersection points. Yep. So let's start with that. Okay, I'm going to do the one on the left. If someone else can do the one on the right, that would be very helpful. Okay, so the x value is really all you need. It's 2.28. So this point is 2.28, negative 1.3. And what about the one on the right? Like 4.0. Yeah.
Yeah, 4.004.
4.004. So
College.
let's say 4.004. So that's really 4.00. Okay. So now, how many sections of that blue graph are above negative 1.3? 2. There's this section. So we'll call that section 1. And section 2. Okay. Let's describe section 1. Where does section 1 start?
0.
It starts at 0. Can I include or not include 0?
You can't.
I can include it. Where does section 1 stop?
2.28.
Stops at 2.28. Include or not include?
I don't think you can.
You can't, because this is not an equal to. It has to be above the horizontal, not equal to it. So what kind of symbol do I want?
The U, the weird, like...
Well, we need that, but we need something else.
Parentheses.
Yep. Or, where does interval 2 start?
At 4.
Including or not including? Not including. And where does interval 2 stop? 2 pi, including or not including?
Not included.
Not including. That's your answer. That's where you are above negative 1.3. Okay. Any questions on that? So that's 6-3. So we got about 6 minutes. I'm going to try to put the topics up. If I don't, hopefully I'll get them on the video, and then it'll go online in theory. Okay, so as far as homework, I'm not going to worry about the homework from the first part of what we did, graphing the phase shift, period change and amplitude change. That is on the test. The only homework is going to be page 340.